All right, so today we're going to be talking about two different things. We're going to be talking about how to solve inequalities with one variable, and then we're also going to be talking about how to write inequalities with one variable. So as far as how you would write it down, if the problem was in word form. So with today's information, we're going to basically be solving. We'll be doing some of the same things we've been doing, so you'll probably pick up on it pretty quick. But we'll need to talk about a few things as we go. All right, so the first thing we're going to do, I have this up here on my board. You can write it on the back side of your notes if you want to flip your notes over and put it on the back. But the first thing we're going to talk about is some of the information you're going to need for today's notes. So the first thing we're going to have is the golden rule of inequalities. Anytime that we have an inequality, now if you're not sure what an inequality is going to be basically your less than, greater than signs, okay? Or less than or equal to, or greater than or equal to signs. Those are going to be your inequalities. So anytime that we have an inequality, the golden rule for inequalities is that if I divide by a negative or multiply by a negative, I must flip the signs. So the key here is I've got to flip the sign. So if I divide by a negative or multiply by a negative, I must flip the sign. And we'll talk more about what this golden rule means, but we need to keep that in mind with our problems here. That when we multiply by a negative or divide by a negative, which most of the time you're going to see division here. Usually it's going to be when we divide by a negative. So when I divide by a negative or multiply by a negative, I must flip the sign. All right, so bless you. So in these type of problems, what we're dealing with or what we're working with here is basically we're going to be taking these problems, working them out, and then we're going to graph them on a number line. So with a number line, what I'm talking about there is basically a line with numbers on it. So it could have like -3, -2, -1, 0, 1, 2. You get the idea, right? A number line is just a line with numbers on it. So today when we graph a number line or graph a line with numbers on it, we're basically going to be doing two things. The two things we're going to be looking at is our signs, okay, less than and greater than. And then we'll also be looking at less than or equal to or greater than or equal to. So basically how this will work is whenever we have less than or greater than, we're going to say that's going to be what we call an open circle or an open dot. Now what an open dot looks like is basically just a circle with nothing filled in it. So when we graph something on a number line, we'll use an open circle to indicate that. When we have less than or equal to or greater than or equal to, we're going to use what we call a closed circle. And a closed circle is basically, once again, a circle, but this time it's going to be shaded in. So what that's going to do for us is going to represent when we have a problem that is equal to and a problem that is not equal to. So basically it's going to identify whether or not the inequality has a line underneath it or if it doesn't have a line underneath it. The second thing we're going to pay attention to is the direction of the sign. So anytime we have less than or less than or equal to, the direction of this is actually going to take us to the left. Okay? That's going to take us to the left. Now, you can pay attention in a couple different ways. We know that less than means the number has to be to the left because all of our numbers that are to the left are always less than. Or you can kind of look at how these signs, you see how these signs here, they kind of make an arrow pointing to the left? See how that makes an arrow pointing to the left? That's going to tell us that we're going to the left in our problem. The key here, though, is if you do that, your variable always has to be on the right side. So if your problem is like x is less than 10, then that would tell us that we're going to have an arrow going to the left, and we know that because our variable is on the left. If it's flipped around, then we have to flip everything around to make it look right. So keep that in mind. Variable always needs to be on the left. If it's greater than or equal to, then we know the problem is going to go to the right. So that would be an indication that it's going to go to the right. All right, let's look at a quick example of this. Okay, let's look at a quick example and see what we come up with. Is everybody good with the notes? You need to pause the video at this point. You can pause it and look at your notes. All right, if everybody's good, we'll go on to our next one. So in our next one, we have example 1. So in example 1, it says solve and graph the inequality on the number line. So we've got to do two things here. Solve it, and then we have to graph it. So to solve this one, we basically want to say 7x minus 19 is greater than or equal to 2x plus 1. So to solve a problem like this, we have to use our operations. We have to basically move all of our x's on the left side, all of our numbers on the right side. So to solve a problem like this, first thing I'm going to do is I'm going to subtract 2x from both sides. And I'm going to get my x's on one side. So when I subtract 2x on both sides, the 2x's cancel out. And 7x minus 2x is going to give me 5x. And then I'm going to be left with 5x minus 19 is greater than or equal to positive 1. Next, I'm going to move my 19 on the other side. So I'm going to add 19 on both sides. The 19's cancel out. And that's going to leave me 5x. And that's going to be 5x is greater than or equal to 20. And then I'll divide both sides by 5. 5's cancel out. And since I divided by a positive number, the sign doesn't flip. So that's going to be x is greater than or equal to, and 20 divided by 5 is 4. So this is how I would work a problem out if I was solving an inequality. Now, next thing I want to do is I'm going to take that same inequality and I'm going to put it on a number line. Now, for this particular number line, I want numbers that are around 4. So you can start with a number, maybe a couple numbers less than 4, and then go a couple numbers above 4. But I always try and put my 4 somewhere in the middle of those numbers. It doesn't have to be exactly in the middle, but close to it. So with this one, I'm going to use the numbers 1, 2, 3, 4, 5, 6. Okay, so you can see how my 4 on my number line is somewhere in the middle of all these numbers. Now, thinking back to our chart a second ago, we said that if x is greater than or equal to 4, then the greater than or equal to sign, first off, is that an open dot, or an open circle, or a closed circle? Closed, because the equal to indicates that it is a closed circle. So above the 4, I'm going to put a closed circle. And then since my x is on the left-hand side, I can then look at the arrow that is created by my sign to tell which direction this is going in. Now, I can read this as well and say this is x is greater than, so I'm going to shade all the numbers greater than. Or I can look at it and say x is pointing to the right. See how this arrow looks like it's going to the right? So that would mean that I would want to draw an arrow going to the right, indicating that 4 has to be any number that is 4 or greater than that number. So that's how I would also graph this on a number line. Let's look at one more example before we try one on our own. Let's look at B. B says that we have 1 minus 5x is greater than x minus 3. So first thing we want to do here is we want to move our x's on one side and our numbers on the other. Now understand, we can do this step, we can save some time here, and we can do this step at 2 steps in one here. So what I'm going to do is I'm going to move my x over here, so I'm going to subtract x from both sides. And then at the same time, if I'm moving x's to the left side, I want to take this 1 and I want to move that 1 to the other side. So I'm doing 2 steps in one here to save myself some time. So I know 1 minus 1 is going to cancel and give me 0. I know x minus x is going to cancel and give me 0. And then when I simplify this down, negative 5x minus x is going to give me negative 6x. And that's going to be greater than negative 3 minus 1 is going to be negative 4. Now, when I solve this problem, I have to divide by negative 6. So what do we say happens when we divide by a negative number? We have to flip the sign. So here when we divide by a negative 6, those 6's will cancel out for me and give me x. But the sign in the middle has got to flip. So what I mean by flip is it's going to change from greater than to less than. And that's only when I divide by a negative number. Okay, dividing or multiplying by a negative number. So if the number on bottom is ever negative, then that means I have to flip the sign. Now that last part says negative 4 divided by negative 6. So what I would suggest is with fractions, I would use a calculator. So negative 4 divided by negative 6. And when I solve that in my calculator, it's going to give me a fraction of 2/3. So I find my answer here to be x is less than 2/3. So to graph this one on a number line, 2/3 is a little bit different. So what I'm going to do here is I'm going to actually do 0, 1, and 2. And I know 2/3 is a number that comes between 0 and 1. And 2/3 is about 2/3 of the way up the problem. So I'm going to put a line here, and I'm going to indicate that as 2/3. So with 2/3 here, paying attention to my symbol, all right, paying attention to this symbol, is this going to be a closed dot or an open dot? Open, because it doesn't have the equal to, so that's going to be an open dot. And then the x is going to be less than, so that means it's going to go to the left. And we can tell by the direction it's pointing, right? This is pointing to the left, so that's going to be less than, so it's going to be all the values that are less than. So that would give me a graph of my line. All right, go ahead and see if you can work problem C. And then if you have questions about it, you can raise your hand and let me know. Or if you don't have questions about it and you feel like you've got this down, you can go ahead and move on to the next video, which will be talking about how to write them in a form that is word, or in a word form. Okay, so how to go from a word form into a problem that's like this.